Hello everyone, welcome back to our channel. We were discussing about maths, class 11th NCERT. Let's start with the third chapter, trigonometric functions. Trigonometry is derived from two words, trigon and metron, which mean trigon means triangle and metron means measure. So trigonometry is the measure of sides of a triangle. We know what angles are, and we have always measured angles in degree. There are other units to measure angles as well, known as radian and gradient. In this book, only gradient is introduced, so we'll study only degree and radian, two measures of an angle, not gradient. Angles. Let's consider a ray AB. A is a fixed point and B is a variable point. This is a ray, and let this be the initial value. Initial value of this ray AB. A being fixed and B and AB being movable, you can easily rotate this AB in this direction from AB to AB dash. This movement is anti-clockwise direction. If you draw a clock, let's draw a circle representing a clock, and let's put numbers on it as we have on a clock. If a person is standing on a clock anywhere on the circle, let's say this point P, there are two options with this person. Either the person can move in this direction or in this direction. We know that as time progresses, your clock, the handles of a clock move in this direction. This is called clockwise. It is the movement of the handles of a clock are moving in a particular direction. This direction is said to be clockwise. So this direction will be clockwise and this direction will be anti-clockwise. This movement is in anti-clockwise direction. Similarly, if you consider the same points AB over here, this will be the initial value of your ray. Again, A is fixed and the whole AB is movable. You can move AB from this point to AB dash. This movement is clockwise in nature. The final positions that they reach are said to be final values. So AB dash is the final value of your ray. Similarly here, AB dash is also the final value of your ray. The point which is kept fixed is called the vertex. Now, if you move in anti-clockwise direction, the angle so formed will always be positive in nature. So you have a positive angle here. This is irrespective of the measure of angles that you're using. If the angle is measured anti-clockwise direction, then it is called as positive angle. Here the angle AB is moves from the initial value moves from AB to AB dash, which is clockwise, and clockwise angle is always negative in nature. So you have a negative angle here. If this value is 30 degree, this value will be equal to minus 30 degree. So first, degree. What is a degree? If you have a line, a ray AB from A to B, and if you keep on rotating this initial value, let's call it a side instead of value. Let's call this a side. So initial side and final side, because if a ray is closer to a side. This is your final side, and this is your initial side. This would be initial side. So if you again have A as fixed, and B as movable, the maximum, if you keep on rotating, you'll end up on the same line AB. Your B and B dash will coincide with each other. And this AB dash becomes equal to your final side. The maximum angle that you've covered will be 360 degree. This is something that we already know. And the structure so formed will look something like a circle. The path of AB will be in this direction. We are considering it in this direction, and B in anti-clockwise direction. And the points, the positions of B, the different positions of B will form the circumference of the circle. Now the maximum angle is 360 degree. If I divide this whole circle into 360 different parts, each part will be called as 1 degree. The same thing is represented or written here. 1 degree, the measure of 1 degree is equals to rotation of 1 by 360th of a complete rotation. Say this is AB, and next you're moving to a different position, which is forming an angle of 360 degree. This angle formed is 1 upon 360 degree. The angle formed between OB and this next point, say B dash for the time being. Similarly, if you add up all the 1 by 360th degrees together, you will form a total angle of 360 degrees. The definition is not very important, but you should know about it. We know what a degree is. We know the maximum degree covered by a circle at the center, which is the vertex, will be 360 degrees. Second measure is radian. Now to understand radian, we'll assume something. We'll assume this radius of a circle is 1 unit. A unit can be any length measure, meter, centimeter, millimeter, etc. There's a center O, which is fixed. There's this point P, which is variable. That means it can move. We are moving it in anti-clockwise direction, covering a distance along the length of the arc. This is along the length of the circle, along the length of the circle or circumference of the circle, measuring in a distance of 1 unit. Whatever measure you have, if this is 1 meter, this will also be equal to 1 meter. If this is 1 centimeter, it is 1 centimeter, and so forth. Reaching a point P dash. We know that OP dash is also the radius, so this will also be 1 unit measure. The angle so formed over here at point O, this angle is called as your 1 radian. Now, degree is represented by a circle to the power circle, and radian is represented by small c, or half a degree. So 1 radian. If this person, after covering this distance, after reaching the point P dash, further decides to move ahead and reach another point P double dash, then, and covering a distance of 1 unit again, the angle formed between P double dash, so the angle P double dash OP, P double dash OP, the whole angle, this will again form 1 radian, and the whole angle formed will be equal to 2 radians. This is what we've understood till now. What if you have to generalize it? So let's consider a circle where the radius is not 1 unit, where the radius is anything but 1 unit. Let's consider the radius to be R. O is the center, and this P is point P. This P is moving in anti-clockwise direction, and it covers a length L and reaches a point P dash. Again, this is OP. This will be equal to R, radius. Now, the angle which is formed at the vertex, let's assume that angle to be equal to theta degree. Theta radian, sorry, in radian. Then there is a relation between this angle in radians, length of the arc, and the radius of the circle. Theta radian is equals to L upon R. So your L is equals to R theta. What do we have next? Next, we know that the complete circle formed. Let's consider a unit circle first for this, because now we are comparing degree with radians at the center or the center of the circle or at the vertex. So if you have a unit circle, 1 unit, we know that the circumference of the circle is equals to 2 pi r. For a unit circle, r is equals to 1. Hence, substituting this, you get circumference of the circle is 2 pi for this particular circle of unit radius. We also know that this circumference means 1 revolution. And we know that 1 revolution in degrees is 360 degrees. So by default, 2 pi radian, even if you do not mention the c, it becomes radian by default. The angle becomes radian by default. So 2 pi radian will be equal to 360 degree, or dividing by 2 on both sides, pi radian will be equal to 180 degree. If you further divide it on both sides, you'll get pi by 2 radian will be equal to 90 degree. This is standard conversion factors between radian and degrees. Now, we know that if one quantity is known to us, like this is known to us, one relation is known to us. And in the second relation, if one quantity is known to us, you can easily determine the other quantity by unitary method or something like this. Y degree over here is equals to 360 degree upon 2 pi radian into x radian. Similarly, x radian is equals to 2 pi radian upon 360 degree into y degree. Now, instead of y degree, let's call it degree measure. So, degree measure is equals to 180 degree upon pi. I've reduced it. So 2 and this is 180 degree. And this is radian into radian measure. Similarly, one radian measure will be equal to pi upon 180 degree into degree measure. So, radian measure will be equal to pi upon 180 degree into degree measure. These formulas are very important from calculation perspective. Next, now from the same relation, we have 2 pi radian is equals to 360 degree. What will be equal to 1 radian? 1 radian is equals to 360 degree upon 2 pi. Or 1 radian measure is what do you mean by 1 radian measure? So now 1 radian measure considering 1 degree. One radian measure, if radian value is given to you, what would be in degrees? So you're calculating degree measure for it. Let's give it a variable. Let's call it z degrees. So you have to calculate the value of z degrees, which is equals to 360 degree upon 1 radian upon 2 pi radian into 1 radian. Therefore, z is equals to 180 degree upon pi radian. This can be calculated 180 degree upon 3.14, which will approximately be equal to 57.2958 degrees. Now, in degree measure, 1 degree can further be split into smaller measures. 1 degree is equals to 60 minutes. This dash, or something which looks like a complement, is called minute. It has a similar meaning as to the minutes and time, measured in time, but we will keep them separate as of now. So 1 degree is equals to 60 minutes. Similarly, 1 minute is equals to 60 seconds. Seconds is double dash. So you can convert this into minutes if you like. It will give you approximately 57 degrees and 16 minutes. So you're converting 0.2958 degrees into minutes. And 1 degree is equals to 60 minutes. So the required value, say x minutes, is equals to 0.2958 into 60 minutes. Multiplying this, you get something like 16 point something. So we are not calculating this further. This is the value for, this is the degree equivalent for 1 radian. So 1 radian is equals to 57 degree 16 minutes. Now, to carry on further, you can also go ahead with the degree conversion if you like. So 1 degree will be pi upon 180 degree radian. 1 degree will be equal to pi upon 180 degree. And this value will be equal to, in radians, this value will be equal to 0.01746 radian. To carry forward in this chapter, we should know about the basics of 9th and 10th standard trigonometric functions, trigonometric formulas. So what I'll do is I'll give you a list. I will discuss the list of formulas that we've already covered in 10th standard CBSE. I guess 8th and 9th chapter. And then we will move on with 11th standard trigonometric formulas. So see you in the next class. Thank you.